Hello, everyone. My name is Michael Richardson. I'm a product director here at Octopus. I joined Octopus back in 2015 as an engineer, and I have spent the last 8 years thinking about release pipelines. And the world of release pipelines has changed a lot in that time. So I still feel like I know nothing, which is a depressing thought. But today we're going to talk about real-world release pipelines with GitHub Actions and Octopus Deploy. So the inspiration for this presentation comes from the fact that we've been working a lot with GitHub Actions recently, figuring out how we can make sure that Octopus integrates seamlessly with them and that it complements GitHub Actions really nicely. And what we realized while we were doing this is that there are hundreds of blog posts and plenty of guidance for creating simple CI/CD workflows. What there's not a lot of resources available for is the type of problems that you hit when real world organizations start to model their release pipelines. And we think we can help because if there's one thing we do at Octopus, it's spend a lot of time talking to our customers and other folks in the industry as well about their challenges in modeling these release pipelines. I've said the word release pipelines a lot. So with that, what we're going to do today is to dive in and take a look at what some of those problems are, these real world problems that people hit. And we're going to see, using a demo application, how we might model them using a combination of GitHub Actions and Octopus Deploy. And we're going to use that as the excuse to show you some of the nice features of Octopus, some of the nice features of GitHub Actions, and most importantly, how the two tools can work together really nicely to solve these, because we think they can. And so I will start by, let's take a little baseline here. So this is the type of workflow that you might see in a typical Hello World blog post. And we're going to use this as our baseline. So you see we've got a build and a couple of deployment stages to environments. Okay, great. Now, what are the type of problems that we're going to hit as we move past this? So first of all, CI is not CD. This is a drum that we beat relentlessly here at Octopus. CI is not CD. They're a completely different set of concerns. CI is all about ensuring that the code that you commit meets certain requirements, like, it compiles is a good one, it meets coding standards, unit tests pass, etc. CD, continuous delivery or continuous deployment, is all about getting that code into production. So different problems. They have different events that trigger them. They have different folks who interact with them. And the artifacts are different. So in CI, the thing that is typically being kicked around is the git commit. In CD, the thing that is being progressed through those environments is typically a set of built artifacts, what we at Octopus would call the release, and the container images and zip files or whatever it might be. So CI is generally stateless, like you can generally rerun CI from the same commit and you're going to get the same result generally. CD, that is not necessarily true for. CD has state. You care a lot about what's happened in the past and what the current state of the environment is. And finally, CI is, in our experience at least, generally much more similar across organizations and across applications within organizations. There are a few variations, but the general gist is usually the same. Like a Go build or a .NET build look pretty similar. CD, this is definitely not the case for. It's very customized to each organization's requirements and each application within that organization's unique set of needs. Okay, so that's probably a good cue, I think, to jump over into our demo application over here. So what we've got set up here is a Git repository that's going to represent our sample application today. It's a simple little Go application. The application itself is not important here. What we're interested in are the release pipelines for it. So let's jump in and have a look at our GitHub Actions. And one of the first things you'll notice here, I hope, is that we've split out our CI and our release pipelines. So we've got our CI workflow here, and we've actually got two release pipeline workflows. We've got release main and release pull request. We're not going to spend really any time on the CI workflow today, but it's a very simple, just runs a Docker-based build. But the one thing I think to notice here is that we've actually got this configured to run on commits that we don't want to release. So we want to make sure that our commits keep our repositories in a known state. But for commits to our main branch or pull requests to our main branch, that's what's going to trigger our release workflows. And that is probably a good cue to jump back to the slides for one moment and to skip to our next typical challenge, and that is branch-based pipelines. So, Git has become the place where development teams store everything. So it's probably no surprise that these Git concepts influence the way that we ship code as well. And what we see is it's very common for release pipelines as well to be driven by Git branches currently. Specifically, what we see are things like events like creating a pull request. You often want to deploy to some sort of development environment so you can have a look at the change and test it out. And it's also pretty common for merges to main to be the indicator that this is a commit that's intended for production. So main branch represents production. Again, there's many different ways to hold this, but this is a fairly common one. So let's jump back over into our demo over here and see how we've modeled this in this world. So let's start with our main release pipeline. You can see that it is triggered on pushes to the main branch, and it uses this build and push image workflow, which we'll dive into. We've created this as a reusable workflow because we use it across both our release pipelines in this case. And it's nothing too out of the usual here. We check out, we capture a little bit of metadata that we want to use for the container image name that we're building. We capture a bit of metadata about the branch, again, for the same reason, so that we can stamp it on our container images. We run a Docker build, and we tag our image. We push that build to the GitHub container registry. We've got this over here, which we will come back to later. And that's our build and push pipeline. So let's jump back over to our release main pipeline. So once that build and push has happened, we then log into Octopus and we create the release in Octopus. And this is where we hand off the release to let Octopus do its thing. One nice little new feature here that's worth calling out is you'll notice there are no credentials in this login to Octopus action. So we're actually using OpenID Connect to integrate with Octopus, which is really nice. It means we've configured the trust for this application over on the Octopus side, and we don't need any Octopus credentials here on GitHub. So that's something that's rolling out right at the moment, actually. And that release is created, and that's probably a good point to jump back to our slides and talk about our next challenge over here. So our next challenge we're going to look at is dynamic environments. So historically, the canonical life cycle for an application was something like dev, test, staging, production, this series of static environments that releases would progress through. But the combination of the rise of cloud providers and combined with infrastructure as code tools like Terraform and Pulumi, these mean that it's become increasingly common over the years to want to use dynamic environments. So especially for things like previewing pull requests, there are a lot of advantages to using a dynamic environment rather than a static environment. And just to think about a few of those, well, number one is if you've got a static or one or two static development environments, it means you're sharing them between all the folks building features for that pipeline. So if you've got 3 features you wanted to test at the same time, now you need to share them across 2 or one static environment. And the advantage from the other side is those static environments, they're generally provisioned whether you're using them or not, whereas dynamic environments, you can spin them up, test your pull request, and tear them down again. So let's jump back over to our demo and have a look at how we handle that over here. So let's jump across. So that was our release main workflow. Let's use our release pull request workflow now. So the trigger for this one are pull requests being created on the main branch. And you'll see it starts off like our main release pipeline. It does a build and pushes the container image, and it logs into Octopus. And now is where we do something a little bit different. So what we actually do here is we've used a different one of our Octopus GitHub actions. Before we've created the release, we're invoking this runbook called provision branch environment. We're going to wait for it to finish, and then we're going to create the release. And let's use that as the chance to jump over into our Octopus project. So we've been up till now looking at the GitHub action side of things. Now we're over on the Octopus side. And you can see right away on the dashboard here, we've got a couple of channels in here. We've got our release channel, and this is where our main changes that are applied to the main branch come down. So this more resembles our typical static environment lifecycle. In this case, we've got main, staging, production. So the main one here represents whatever is committed to main at any given time, and we'll have a look at these environments later. But of interest to us right now are these channels. So what these actually are dynamic environments that we've created just for pull requests to deploy to. So let's jump into our runbooks over here, and you'll see we've got a create branch environment and a destroy branch environment runbook. And this create branch environment runbook, what it actually does is it runs some Terraform to provision a bunch of resources in Octopus for the environment. So this is just a little script. It's not doing anything particularly exciting other than doing a Terraform init and running some Terraform. It actually, the interesting thing is we create a new Terraform workspace for each branch. This is what lets us reuse the same Terraform across all our dynamic environments. And let's jump over and have a look at that Terraform, shall we? By the way, I'll make this repo available at the end of the presentation for anyone who wants to have a look afterwards. So if we dive into the Terraform that we're using here, we provision quite a few Octopus resources here. We're actually spinning up a new environment. We're spinning up a brand new life cycle that contains only that environment. We're spinning up a brand new channel that links to our new life cycle, and we're creating the Kubernetes cluster deployment target to represent this environment. And if we jump back over, you can see the result of this over here. So in this case here, this is a feature, an example of a feature that we might have an open pull request at the moment. We've called it quick ship. If we jump to our library and look at the life cycles, you can see we've got our release lifecycle here, the one I mentioned, main, staging, production, and we've also got these temporary life cycles for these features. They have only the one environment in them. And if we jump back to let's jump to the infrastructure and have a look at the deployment targets. So we've got our Kubernetes cluster targets here. And you can see we've got some static targets for dev, staging, production, but we've also got these dynamic targets that we've spun up with our Terraform for these features. And they live just in the temporary environments that we've got. So the end result of this is that we get this nice dashboard that shows us the dynamic environments that are available at any given moment as well. With that, let's jump back to our slides for a moment and look at our next challenge. So we've talked about dynamic environments, but production environments are different. So while we might use these dynamic transient environments that we spin up and spin down, which are great, they're great for development environments, but this is rarely true for production. So Production is almost always a pet. It's not cattle. It has a long-lived database associated with it. It has specific access rules. It has monitoring hooked up to it, et cetera, et cetera. In fact, what we often see, as we've just looked at, is that there's usually a handful of these static environments, more than just production. It's very common to have a production-like staging environment to test in with similar hardware, et cetera, before you get to production. Sometimes you might have a disaster recovery environment as well. But yeah, the key thing is here that it's really common to have these static environments alongside the dynamic environments that are treated slightly differently. So if we jump back to our demo application, let's have a look at some of the specific things of this. So another thing that makes production a little different to other environments is that the infrastructure in it can be quite different as well. So if we look at our Kubernetes targets over here, we've actually got, in this case, two Kubernetes clusters in the production environment. So in this case, we're simulating like a multi-region scenario where you want to deploy to US and Europe or whatever it might be. And so the nice thing in general that Octopus lets you do is completely abstract your deployment process away from having to know anything about this infrastructure. And how do we do that? So let's jump back into this. So our deployment process here isn't doing much. It's just running a customized step to deploy the Kubernetes manifests. And if we look in here though, any of you who are familiar with Octopus will be familiar with this concept that steps in Octopus get given these roles. So we want to say we want to run against the SHIPPED23 Kubernetes infrastructure. And so when a deployment happens, it goes to the environment that it's being deployed to and uses that role to fetch the right set of deployment targets to deploy to. And that might be a dynamic cluster we've just spun up, or it might be multiple static production clusters that we've configured. And this is nice because it avoids us from having to know anything about this. So I think the key takeaway here is that different environments are a little different. And we'll talk a little bit more about that in a second. But first, let's jump back to our slides and jump to the next one, which is release management. So this is another real challenge when you start building real-world release pipelines. And I think this idea of release management is one of the most under-addressed topics in software development in general. So the way that you move your code and artifacts from developers' keyboards through to running in production has a huge impact on, not to overstate it, but your entire organization. So, you know, it really affects the velocity and the quality with which you can deliver software, which makes it interesting enough on its own. What makes it even more interesting is it's definitely not a one-size-fits-all problem. So for any rule that you can think of in regards to release management, any best practices, chances are we've spoken to someone with a very good reason to break or bend them. You know, you see this come up periodically with the should you deploy on Friday or not deploy on Friday debates that typically fly around Twitter every now and then. And the reality is that every organization has their own perspective on this. They have their own goals, they have different constraints, they have different appetites for velocity versus risk, and there's good reasons for all of this. We could do a whole topic on release management, and we probably should one day. But for now, let's jump back over to our demo application over here and see how we handle some of this in our little application. So let's jump back to our main release pipeline. So whenever a commit gets merged to main, we build it, obviously, and then we create a release for it, for every commit. And you'll see that when we create this release, we send it down the release channel in here. And the release numbers, the versions that we're using for these releases, actually, we can jump over to our package repository and we can have a look. So you can see some of the container images that we've pushed to our GitHub container registry here. They use the branch name and the GitHub run ID as the package ID in this case. It works for our purposes. Your mileage may vary on this. So So we create the release in the release channel, and what happens there? Let's jump back to our project. And if we have a look at the life cycle for this project, for this channel, we can see here, this is our release life cycle: main, staging, production. As I mentioned, main we basically treat as a tracking branch for main. So every commit that gets pushed gets immediately and automatically deployed to our main environment. So you've always got an environment that represents your main branch at any given time, which is nice. For staging and production, what we do in this case is we've set up release triggers to say we want to promote that main branch to staging each day at 9 o'clock in the morning. So that's our cadence that we use to effectively batch a release. We think of it often as a release train. That's when the release train leaves. And every day we also take what's in staging and promote it to production at 8 a.m. So we do it just before, so that if we need to roll back, we can always have a look at what's in staging. So that's the release train, the way that we've modeled it for this application here. And again, there's no right way to do this. It depends very much on your own requirements, your application's requirements, but that's what we've done here. And we're also not restricted to those time triggers. So let's imagine we found a bad bug in production and we wanted to push it through. There's absolutely nothing stopping us from coming in here, committing our change. It'll be deployed immediately to the main branch, and we can bang on these deploy buttons here and push it all the way through to production as fast as we're comfortable to do with. So we've got a few different ways to handle things. If we jump back over and have a look at our release pull request workflow, again, we create the release in Octopus every time a commit is made to a branch which has a pull request open on it to merge it to main, for a pull request against main, I'm sorry. And but you'll notice this time the channel is dynamic. So the channel isn't fixed. The channel it uses is the one that matches the branch that's been deployed to. And this won't surprise you, but these match with the single environment that's automatically deployed. So every change to a pull request gets automatically deployed to its own custom environment, and that's it. That release does not progress to any other environments. We want that change to go somewhere else. We merge it to main. Again, that idea of a branch-based workflow is how we trigger that. So that is how we've modeled our release management in this project. Let's jump back to our slides for a moment and talk for a minute about roles and responsibilities. So this is the next challenge we want to talk about for modeling real release pipelines. Not everyone in the world is a developer, and I know I was shocked when I first realized this as well, but it is true. And again, back to our first point, this is one of the ways in which release pipelines really differ from build pipelines. It's very common for a build pipeline for no one to care about it other than the development team that's working on that project. Generally, this is not the case for release pipelines. For release pipelines, you really do want to segment your rules and responsibilities. So what am I talking about there? It's very common, especially in large organizations, for development teams to be responsible for deployments to the lower environments, the one that they own. So for example, our transient pull request environments in this case, possibly that main branch environment. And then for the production environments, for them to be owned effectively by a different team, some sort of centralized operations or platform team. And you sort of want some walls in between those two. And this is really where Octopus shines. It's got a nice set of features to enable this. So if we jump back over to our demo application for a second, the sort of things that you can do in Octopus here. So let's actually just have a look at our teams here. So what we can do is, you might have members of a development team that have the ability to manage environments and deployment targets for the development environment, but not for the production or staging environments. And on the flip side, they have full project contribution rights for the project itself. And then on the other hand, you may have you may have your ops teams configured where they have various infrastructure management capabilities across all environments, so they can absolutely go into production and manage the infrastructure there. On the flip side, they're not too interested in changing things within the project. They don't mind so much. So what this lets you do is set up those kind of clear boundaries between the two groups. And excuse me, I'm sorry. And again, as we mentioned earlier, the way that the deployment process lets you use those roles really lets you abstract those away. So the time you're writing the deployment process, you don't need to know which environment it's going to be deployed to. You can even segment it further than that so that you can't even see certain groups can't even see these other environments. You've got a lot of power at your disposal to be able to really configure those boundaries between the teams. And yeah, let's jump back to the slides. And we will jump to our next point, which is that it's never perfect. So, CD pipelines are complicated. They integrate many tools, cloud providers, Kubernetes, tools like Octopus and GitHub Actions, Terraform. These are complex tools solving complex problems. The reality is you are going to hit snags as you model these scenarios. I'm too embarrassed to show you how many runs it took me in Octopus and GitHub Actions to configure this example, but it was many putting this demo together. And I think it's important to remember that perfect isn't the goal for creating these type of pipelines. Better is always the goal. We often find that the folks we talk to are maybe almost embarrassed about the state of their pipelines because they assume that everyone else's are perfect and very advanced. And definitely here to tell you this is not the case. All the organizations that we work with exist to deliver value to their customers, not to have the world's most perfect deployment pipelines. So I think the key takeaway here is being pragmatic and solving the problem that you have in front of you, and not being realistic that it's not always going to be exactly the way that you want it to. And that was a interesting little rant, but I want to give you an actual example of the way that this played out in this project. So if we jump back over to the demo, I was up late one night as I was putting this together, and I was really struggling because in this dynamic provisioning, was trying to get it so that the authentication was working with the dynamically created Kubernetes clusters. And if you've ever worked with the identity management in Azure AWS, you'll know it's the most complicated part of the whole system. And I was struggling to get it working, and I couldn't get the Terraform to provision it correctly, and it was frustrating me. And so what I wanted to do then, to cheat as we do, is to come in, and all I wanted to do then was to select login with administrator credentials. I was like, forget about using the Azure AD RBAC. I'll just, these are just dev sandbox Kubernetes clusters. They're not connected to production in any way. The resources in them get torn down regularly, so I'll just provision it like this. Except there was an issue with the Octopus Terraform provider we use where that was struggling, and I thought I might have to make a change to that. And where I landed in the end was that, as a temporary measure, I decided that I was just going to add a manual step to the runbook so that for the first time it's run, and the way that we do that is in here. The first time when we actually provision the Terraform workspace, we set an Octopus output variable saying that we've just created the workspace. And then in this next step, we bind it to it, and we run only if that is true. And it sets a manual action so that pauses the runbook, and we can come in and check that checkbox here to say use local admin access in this case, and then continue. Not perfect, but you know what? We'll see how much it annoys me, and we'll fix it if it annoys me too much. And I think, as you model these complex real-world pipelines, you're going to hit many issues like this, and being pragmatic is the way to get around them. So let's jump back to our slides for one last time and say that it's time for the working demo. So back to the demo again for a second, please. And I am going to well and truly invoke the demo God's wrath here by looking to do a full end-to-end workflow of how this plays out. So let's do it. What we're going to do is let's create a branch for our new feature. So we've got quick ship, we've got safe ship. I think we need a secure ship branch. Let's do it. Let's go and make a code change that we can push through. See, this is going to make it more secure because we're going to remove some exclamation marks. They were definitely a risk. Let's commit this change and see what happens. So we jump back over to our GitHub Actions here. And we can see that our CI is running. So this is our CI build, making sure that our code compiles, that our unit tests run, all those good things. Because of course we always want to have our code in a known good state inside our repos. But you know what? I think it's time for us to create a pull request for this change. Pretty happy with it. Let's create the pull request. Now let's jump back to our actions and see what happens here. So now you've seen that we've created that pull request and that's triggered our release pipeline. So this is the one that's going down the release pull request workflow. Let's dive into here. Our CI there passed, as we would hope. So this is going to build and push our container image. So let's watch that happen. And what we should see in a minute is that show up in our GitHub container registry over here. And there we go. So as I mentioned earlier, we are labeling our, we're tagging our images with the name of the branch and the run ID. So we've got our secure ship. And if we jump back here, that workflow is now triggered the runbook in Octopus. So let's jump over and have a look at that. So we can see our create branch environment runbook is being executed here. Very nice. That's going to go and run that Terraform that we looked at earlier. So it's going to be creating the environment, the lifecycle, the channel, the deployment target in Octopus. And now we've seen that our manual intervention has kicked in. So this is saying that it's paused and awaiting for us to do something, which I really like this as a pragmatic feature in Octopus. So let's jump over to our infrastructure tab and look at the one that we've just created here. So here it is, our secure ship. So what we can come in here and do is say, let's log in with the admin credentials for that. It's not best practice, but it's a temporary development environment. So let's go and continue. That runbook will now complete. What we should see is the next job that will run is we're now creating the release for that in Octopus. So if we jump back over, we should see, here we go. We've created the channel, we've created the release, and it is now getting deployed to our brand new environment that we've just spun up for this. One of the really nice new features recently as well is this Kubernetes object status. So we can actually see in real time the status of the Kubernetes objects as they're being provisioned here, which if you haven't checked this out, I definitely recommend that you do. And we've seen that that's succeeded. So we're not going to worry about actually looking at the application over there. That's not the purpose today, but this is where we would normally go and use it and make sure our change was what we wanted it to be. And let's assume that we have, and we verified our pull request. So what we can do now is jump back over to GitHub and look at our pull request. So this was, let's say we're happy to merge this. So we've now merged that into main. So let's have a look what happens with our actions now. So two actions have triggered here. One is the release. We're now creating a new release, which is going down our main release channel. The other one is one to deprovision the temporary environments that we've just spun up. So let's jump over into Octopus and see how this plays out over here. So we'll notice that for this main release workflow, we still do the build and push. But what we don't need to do is provision any temporary environments. It's going to create a release in the release channel here, which will be automatically deployed to this main environment any second now. And meanwhile, our destroy branch environment runbook should also be running over here. Let's have a look at that. So that's run there, and that will have torn down our secure ship environments. So if we jump over here, you'll notice they've fallen off the dashboard now. They've been cleaned up and all gone. And our release to our main is now rolling out. And once that's done, we'll be able to go and view the application as it stands on the main branch. And then automatically the following morning, it will be promoted to staging. And assuming no issues are found in there, it'll be promoted to production following from that. And success. So that is an end-to-end run through. Well, I guess actually it's not quite end-to-end yet, is it? We should come back in and we can even, if we want to, if we're impatient, we don't want to wait for the next morning, we can kick this along and trigger the staging deploy in here as well. But yeah, I hope that's an interesting look at the way that we can model some of the more complicated real-world problems you hit when you start modeling release pipelines, and how you can do them you can handle those using a combination of GitHub and Octopus together. And if we jump back to our slides one last time, we will put this up so that we can use that as the resource. You can come along and have a look at that repo on your own time, and it will stay there as a useful reference. And yeah, I hope this has been informative and helped show how powerful Octopus Deploy and GitHub Actions can be together for modeling CI/CD workflows. And with that, thank you for having me.